Okay, welcome back, students. So here we are. We're trying to answer the question: which two of these triangles are congruent to each other, and give a reason for your answer. Okay, so I've just done up a list of the two side conditions, and we clearly identify that A and D have the same side conditions. So we can say A and D have 2, 3, 4 side condition. Okay, and then so we say both triangles are congruent based on SSS. Okay, you can say triangle A is congruent to triangle D, and this is a two-column approach which we're going to be talking about. And then so your justification is side triangular congruency. Okay, and that's question 3 done. On to question 6. Explain why triangles AOB, the one on the left, and COD, the one on the right, are congruent. Okay, so we start off. Okay, now I'm going to introduce you to the real two-column approach. Okay, so you've got your statements of fact and your justification, and we can number them. So number 1, we can say that BO, okay, line segment is congruent to OD. Now, by the way, you could also say BO distance is equal to OD. The most important thing, which either of those you say is the same, you can say given. We prefer congruency. It's just that, you know, equals more or less gets replaced with congruency in geometry. Okay, now given means it's information they told us. So we always start with 1 or 2 or 3 lines of givens, depending on how much stuff we were given. So the next thing is that AO is congruent to OC. AO line segment is congruent to OC, because for two line segments all have the same shape. You know, this is a shape, and it doesn't matter if it's congruent, it's the same length. That's all. It doesn't matter what direction it's going in. So these two are congruent because we were told, or it's given. Now then the next thing is we're going to get the angle in between them. So this is a side condition, this is a side condition. Now we're going to go and say that these angles are equal because they're vertically opposite. So BOA angle is congruent. Now you can put bars down the side and say they're equal, but as I said, we're learning so much. It's nice to introduce this new terminology, and I don't have to put the bars down. I can just say that angle is congruent to this angle COD. Okay, and why? Vertically opposite angles. Okay, now we have to patch it all together. You always have to finish with the statement you were trying to prove. So we were trying to prove that the triangle AOB is congruent to the triangle COD, and we've proven it based on side angle side triangular congruency. If you wanted to be really cheeky or get it done really quickly, you could have said side angle side triangle congruency. Okay, and a little box to say you're finished, you've done your proof, and on to the next one. Okay, here we have question 9, and we have the parallelogram and we're told it's a parallelogram, so we can make some statements like that these are parallel, that these are equal in length, that these are equal in length, and that this is common. Okay, we'll talk about that. So this is a longer proof now. Okay, so we're asked to show that we're told ABCD is a parallelogram, so there'll be a lot of givens in that because parallelograms are loaded with properties and features. So there'll be loads of givens. Showed it to triangles ABC, the top one, and ACD, the lower, are congruent. Okay. So we're going to be kind of comparing stuff we're going to be comparing sides and angles from the top and bottom. Let's start with the lateral sides. So let's start our proof with that AB is congruent. Now I just want to say something to you. AB is congruent. It takes a little bit of time to write that. You can use an alternative, which is this, which means the exact same thing because it's a line segment. And at the same feature, if you want to say AB, you can say AB with a line on top. But you can say, why would I do that? That takes longer. The thing about this is it shortens up your time. So if we want to start dropping them, we can use a line on top. So I'm not going to do that yet, but we can discuss it. And if you all agree, then that's fine. This is one notation. This is another notation, well known as well. It's just, of course, the book and the syllabus does prefer this. It's just I prefer this because it's quicker. Anyway, I'll stick with this one for now. So I'll say that AB is equivalent to DC line segment, and it's not given. So this time my justification, my two columns, I'm drawing a line down the middle. My justification, and these are my statements. So my justification is, what are we saying here? Parallelogram property, or opposites sides in a parallelogram. Okay, parallelogram's a long word. Don't really want to write it out, but we'll do the shape first. Okay, opposite sides in a parallelogram. Okay, next up, let's go, and that's a side condition. So next thing we'll go with this angle here equals this angle here. This is a transversal. These are parallel lines. Okay, so BAC is congruent. The angle is congruent to ACD. Now I want to say to you, when you look at the book solutions, they'll put the size equals, and it's just not brilliant. Like why say that when you can say they're congruent? This is all about shapes and congruency. So the angles here is equal to the angle here. Now be careful how you go around it. C has to be in the middle. ACD. Okay, so these are equal. Justification, all alternate angles. Okay, and that's an angle condition, an angle congruency. And on we go now to, so we've done this one. Oh, this one here, it's common. Now here's something pretty cool now. So as I'm going around the top triangle, I'm going to cross here, doing the angle, and now down here, so I'm going to call it AC. So I'm going to say AC, what am I calling it? Line segment is congruent, and it coming out this way, you're going over here and going to this angle, so you're going CA. Just reversing the letters. Okay, and it's you can say common. I'm just going to check what the solution said, but a better word is reflexive, which basically anything equals itself, and it doesn't matter. You know, line segments are like, it doesn't matter what way you go, they're congruent. Like there isn't really a direction to them, but even if there was, that would be congruent to that. Okay, I'm just going to look at the marking scheme on the side here. 6, consider this. What am I on now? 6 or 9? 9. Here, I'll bring it in and you can see it yourselves too. So you see the way here they're using definition of a parallelogram. I said opposite sides of a parallelogram. Yeah, that's nice. That's okay. But anyway, well, I want to get down to this. AC is common. Yeah, that's not great. I mean, we're doing better than that, just to tell you that. But I wanted to see that they use common. What did they say? So yeah, well, they've used the word common, so we'll stick with this common. Just another word is reflexive property, which is a property basically that anything is equal to itself. It means the same thing as common. All right, so we've side, angle, side. Now don't forget the last line. So draw. Maybe you can draw a line here. You don't have to, but this is the taking it home. This is the proof. So what you say now is that you go back and you say what we were asked to prove, which is here, this triangle. Got it right? And we'll just go in the order they said, A, B, C. Once you've shown here they're congruent, it doesn't matter what way you go around them. Sorry, that's wrong. You should always go around like correspondingly. So we'll double check they've done that for us, and if they haven't, we'll go around differently. No, they haven't gone around correspondingly. So if they're going from A to B with the top, and then they're going off to this opposite angle, we could use that too, by the way. We should be going from C to D to A. Okay, that's just a little bit lazy. I'm telling you now, that's a little bit lazy in the book. They're doing their best, but they should have done it this way. So always try and go around the same way, because your SAS otherwise gets messed up. Okay, and our justification is triangular. What did I say last time? SAS triangle congruency last time, and this is again SAS. Say the same thing. SAS triangular congruency box. Lovely. Is that it? No, we have one more. Question 12. Okay, here we go. Okay, so let's start off with our givens. So I'm gonna switch over to this quicker, way quicker. DA is congruent to AB line segment. Given. They told us it is because they gave us those ticks. Now you can be saying isosceles, but you know, there's no need. You shouldn't. You just say given. Whatever they told you, they told you. They also told us these angles are equal and they're 90. But important thing is that they're equal. So it's ADC angle is congruent, and we go the same with ABC. Okay. Given. So as I said, you'll often have several of these givens down the right hand side. So the whole big shock for you guys is that we're going on to this whole new approach realm of mathematics and geometry where proof and logic and justification has to occur. It's not an option. So this two column proofing thing is what it's all about. So we've got that. Oh, and look at this common fella here. So but this is side angle, which wouldn't normally be right. So like side angle can be a contradiction. It can be ambiguous, which I'll show you. However, this is an RHS condition, a right angle triangle with the hypotenuse, which is this one, which is common, and a side. Okay, so we're just going to belt on and say AC is congruent to CA, and we just use the word common. And now we have, I'm going to have to say RHS. So here we go. We're ready for it. Now they probably did this wrong again. Did they ADC? The first one can never be wrong. We just have to make sure the second one is done correctly. Is congruent to, so they went along this line and through the right angle. So as long as they say ABC, okay, they got it right this time. Great. ABC. And what are we saying? Why are they congruent? So triangle congruency, RHS condition satisfied. Okay, I didn't have to write that, but I'm writing it now, and there you go. Okay, I'll do solutions to the rest of them in due course, because this is such a new realm of math. You really want to see. I think I'd say to you as an exercise, you should follow my next YouTube video, which will be on all of the rest of them. then just do them on your own. They're lovely. They're not too long, but they're just different. Or it'd be a bit like if you're doing algebra, every single line you have to justify it with, and you cannot skip justification. You cannot transcribe terms. You cannot multiply across by a factor, divide across by a factor. You can't do any of that without justifying it all the way down. Okay, whereas in algebra that's optional unless they ask you to. It's good practice, but it's optional. Okay, students, as always, I'll see you in the next one.